Hi everyone, in today's video we are going to discuss a very important concept that is mentioned as part of the very famous book Designing Data Intensive Applications. We are not going to design an entire system right from the functional requirements, non-functional requirements, etc. We are going to discuss a concept that is applicable at a lot of places, right? So, for example, let's imagine that you have a highly concurrent system where you are either required to book a room or you are required to book a seat. So, when we are discussing a system like this, the very first thing that comes to our mind are movie booking or seat booking applications like in India we have Book My Show, right? So, a lot of those applications actually have this concept underneath, which we are going to discuss today, and that concept is called materialized conflicts, right? So I'll just explain the use case first, and then I'll explain, for example, what materialized conflicts is and where exactly can you use it. So just take an example that you are building something like a meeting room booking for your office or for a building or for your college, right? So you have a fixed number of meeting rooms and people can book those meeting rooms for a minimum of 15 minutes to any maximum amount of duration that you want them to book. Now, imagine that meeting room booking system is highly concurrent, that a lot of users can book the same room for the same time slot in parallel, and then you want that no two people are able to book the room for the same date and same time duration. So how would you essentially design a system that such sort of concurrency is handled? So that is where the concept of materialized conflicts come into our rescue. So what does materialized conflict actually means? So in this example of meeting rooms, the physical manifestation only existed in the form of meeting rooms. But if you see that the conflicts can happen when people book the same room for the same time slot. So, what are your conflicts? Your conflicts are not just your meeting rooms, your conflicts are essentially a combination of meeting rooms and time slots. So, using materialized conflicts, you essentially create the possible conflicts that can occur in future, and then you acquire lock on those conflicts. So, let's take an example. So, let's imagine we have two transactions, transaction 1 and transaction 2. Both these transactions are planning to book a room for a particular time slot, but their time slot overlaps by 15 minutes. Right? So, what we essentially did is in our database, we created rows like that. For room 1 and date 1, from 9 to 9:15, there is one row. 9:15 to 9:30 another row, 9:30 to 9:45 another row, 9:45 to 10 there is another row. And similarly, for the same room and different date combinations, for all 15-minute time slots, we created a row for that. Alright. Now, this transaction 1 wants to book the room, and then it wants to book the room for the date 1 from 9 to 9:45. Whereas this transaction 2 wants to book the same room from 9:45 to 10 p.m. Now, there is an overlap of 15 minutes, 9:30 to 9:45, for which both these transactions want to book the room. So ideally, if these two requests come in parallel, only one of them should be able to book the room. So what we did, we essentially created these potential conflicts. So this R1 date 1 9:30 to 9:45 is a potential conflict between these two transactions. So even before this conflict arose, We created this conflict as part of a row in our database, right? That's where we started with creating rows of 15-minute time slots for every date and room combination in our database. And now, when transactions try to book the room, they need to acquire on all of these 15-minute time slots. So this transaction also need to acquire a lock on all the 15 minutes time slots that it want to book. Now, if some other transaction, let's say in this case, if transaction 1 had already acquired a write lock on this third row, then the second transaction should not be able to book that room, right? Exactly. That's where the second transaction would fail and it would not be able to book the same room for an overlapping time slot of 15 minutes. Similarly, if transaction 2 had acquired a lock already, transaction 1 should not be able to book the room for the same 15 minutes duration that is overlapping with transaction 2. So that's the way we essentially materialized the conflicts as part of our database model, replicated them as rows, and now all the transactions need to acquire locks on them. So that is a concept of materialized conflicts. Now, where exactly can you use this concept of materialized conflicts? For example, if you have a flash sale and you just have 100 phones to sell, then what you can do is you can replicate those phones as part of rows in your database. Let's say phone 1, phone 2, phone 3, and let's say phone 100. We have 100 rows as part of our database. And now there are a lot of people trying to buy things as part of the flash sale. So they just need to acquire a lock on each of the row. And if there are 100 locks already, no other person should be able to, let's say, acquire the phone or have a lock on the room, right? Now let's say if your payment fails later, that the lock could be released and other people could essentially go ahead and book the lock, right? And as we discussed previously in a previous video, right, your lock should then have TTLs as well, because if something happens or fails in between, the lock should be released automatically, right? Similarly, for a movie booking system, what you can do, your rows could be your screen number, your show number, and the time duration, right? Screen number, show number, seat number could be one row, right? So that the same seat could be booked across different shows, right? So if anyone wants to book them parallelly, they need to acquire a lock as part of that row. So if you are seeing that, what we are doing here is we are materializing the conflicts that can happen in future, make them rows as part of our database, so that when concurrent transactions come, one of them need to take a lock to book that seat, to book that room, or to book that phone, so that other parallel transactions are not able to book it. So we ensure only one of the transactions is able to book that seat or room, meeting room, or that phone. This way we are handling parallel transactions, we are handling concurrency, and we are handling that only one of the parallel transactions is able to book that particular slot, room, seat, or phone. This is a very, very important concept. This has been mentioned in this book, Designing Data Intensive Application. It's a very must read. I hope this concept helps you in your interviews. There's one thing left for me to tell you. What are the cons of using materialized conflicts? So ideally, it's usually preferred as a last resort because of the fact that in this case, to solve the concurrency problem, you have to design your database model that way, right? So your database or data storage is essentially coupled with your concurrency control solution, right? And that's not a good way to do that. And also, now in this case, or for the case of a movie booking system, right, you have to have some backup system that essentially pre-creates these rows. Let's say 6 months for the next 6 months duration in the case of meeting booking system, or let's say for the shows coming in next 1 2 months in the case of book my show. So we need to have some auxiliary system that creates or that materializes these possible conflicts as part of rows in the database. beforehand. So all these rows need to be created beforehand. So we need to have another system that does that. Plus we are coupling the data storage with the concurrency control solution, and this coupling is not correct, right? We should ideally have some other mechanisms to control the concurrency as part of a solution. But still, this solution is very helpful in a lot of system design problems where concurrency control is the solution the interviewers are looking for. I hope you find this videos interesting. Thank you. Thank you everyone. Bye bye.